Okay, let's analyze this case study, which is achieving educational equity, analyzing class size impacts in Project STAR. What are we actually doing? What we're doing is just basically following Dr. Olga Casados, this new superintendent of a large urban school district, a budgetary decision. Okay, so the thing is, shall we promote small groups versus large groups? And the objective is achievement inequality. To make this decision, what she commissioned is a quantitative analysis based on historic Tennessee student-teacher achievement ratio, which is called STAR project data. And she wants me to move beyond simple averages and use further statistical tools, in particular, analyzing the Lorenz curve and the Gini Index. Even though the project involves 1,000 students, we are basically using a small subset, okay? And this is actually what we know this data set already. Class type, which can be small or regular classrooms, reading and math scores, and if person just graduated or not. The objective is to compare the Gini index coefficient and the Lorenz curves for one of the scores, and also for small versus regular classrooms, right? What we're going to do is just to follow an R script in RStudio, and finally we will check the outcomes. Good. You have all the workflow here. Okay, you can see every step, etc., etc. But what we will do is just repeating that in RStudio. You can have a look at the data. Remember, we can have it as a CSV or as an Excel. If you double click, you will realize that you can see that this is an Excel with class type, reading, math, and graduated, and this is the type of data we had. It's much better if you want it, if it's in Excel, but we didn't learn how to upload the data in Excel in RStudio, and this is what we are going to do now. So the script, which you simply double click, the script, which was here, called inequality. The script just first calls for the installation of a couple of packages. The first one, readxl, is for reading Excel files. If I click, it will be installed. Okay, when it's blue here, it's fine. And then the other package was called inec for inequality, which we will use for computing inequality indices. Once installed, you only have to install them once, because we don't need to install every package every time we open. Once installed, yes, you have to upload this in the memory. So we call library, read these packages. Okay, done. Next, we set the working directory, which was our working directory. Oh, this is example RStudio. So I have to say here, example RStudio. Okay, remember that the lines here, this is contrary to what we could do here, which is basically as a contrary line. Okay, so this is different. Okay, we set the working directory, and we say that our data is in this subfolder, what's called DSS. We set the data folder, and finally, what is the file path? Look at what we learned here today. File path is data there, which is DSS, and then the file is star.xl. Okay, so we do this, right? Good, no error here. And then now we use the readxl, you see? File path, so this is exactly the file what we're calling. And we will store it as a star. Now we have this data set. Remember, this is the framework we had. We can verify what we were working with. Click here. Yeah, this is exactly what we saw in the Excel file. And you can ensure that reading and math, they are numeric. We have here some indications, but still you can see here. Yes, reading and math, they are numeric. Look, how simple is compute the Gini index? What we have to do is select this, say, I call for the library of inequality, and I say, inequality of what? Star dataset, variable reading, which is this one. What type of inequality index? The Gini index. And we store this as Gini total. I select, I run, apparently nothing happens, but now we print that. We print that together with overall reading Gini index, round Gini total, comma 4 for 4 decimal units. I run it, and you have it. Overall reading Gini index is 0.0329, which is very slow, very slow. We can generate the baseline Lorenz curve. How? We say we're going to do a plot. What type of plot? Lorenz curve. This Lorenz curve, you can see this, is an outcome from the inequality library. And again, we say star dollar reading. So the Lorenz curve for the variable reading within the dataset star. What type of color you want? Well, the red is fine. And we put just some text for the heating. We select. We run. Here we go. Well, as you can see, the Lorenz curve is actually in line with a small value of the Gini index, which is very close to 0. And it implies that the Lorenz curve is very close to the bisector. Very, very close. Good. Let's follow now the question for Dr. Casado, which is actually saying, okay, what about small and regular classes? Are they implying very different data sets? Well, as you can see, we create subsets of data. This is neat. So our group, a total group is this one, is 1,274 observations. But there are people in small classes, some of the people in regular classes. Let's create a subset of the data. So how is this subset? It's a subset of star. And what are the characteristics? Well, those people whose class type is small. I select, I run it. Oh, we have a new group. Oh yeah, so we have star and then we have small. So out of this 1,274, 585 belong to small classes. If we do the same for a regular, subset star class type regular, and we store it as a regular, run, we have a new group. Regular 689, small 585. We have everything here. The sum of this is equal to 1,274. Good. So it's not complicated now then to compute the Gini index for what? Not for, as here, what is it? Yeah, inequality star dollar reading. Now we say inequality, not star, but small reading. And the same applies, Gini index. We do the same for the regular. Gini regular will be the inequality, Gini index, this is the type of inequality statistic. And then we go for the regular subgroup, dollar reading. We can compute it, and then we can also print the outcomes. I select everything, I run it. What do we see? Oh, look at this. For the small group, the Gini index is 0.0332. What about the regular group? 0.0323. Come on, they are very close one to another. If we do that visual comparison, we plot the Lorenz curve for reading in regular and small groups. The regular will be represented in black, the small will be represented in red. Okay, and we do everything in a row, and we put the legend, run. Okay, this is the new graph comparing the both Lorenz curves. They are that close that it's impossible, almost impossible just to distinguish, which is of course normal because these values are very close one to another. So it's impossible. So what is the outcome we can say? Well, I mean, in terms of inequality, at least, the small versus large groups belonging to a, or just studying in a small group versus a regular group, there's no actual implications, right? So this will be it. I hope you liked it.